So welcome back, and we are carrying on with our study of annuities, and let's dive straight into this question 8 on page 20. Okay, and this question just works slightly differently because of this word immediately. So what I'm going to do is I'm just going to show you if it was just for 1 year, all right, so 12 payments. So now normally we would make a payment month 1, month 2, month 3, right through to 1 year to month 12. There would be 12 payments, each payment of X. But what happens here is he starts making payments immediately. All right, so in fact, in 1 year, there's actually 13 payments. Every year after that, there'll be 12 payments. So for this question, 10 years, there's actually going to be 121 payments. Right, apart from that, it works exactly as normal. I don't like it when teachers and examiners try and sort of trick us with words like this, but we've just got to be aware that it does happen. So we've just got to read it carefully. Right, you would only lose a mark if you used 120 instead of 121. You'd only lose 1 mark, but let's just try not to lose that mark. All right, so the future value formula, here it is. Again, hopefully we're getting to know it now. All right, although it gets given to us on a formula sheet, it's really useful if we can just write it down without having to think about it. There it is. Okay, so he's going to end up with 800 Rand. Now we've got 1 plus. Our interest rate is 15%, but that's per year, so we need to divide by 12. They're going to be 121 payments minus 1 over 0.15 over 12. Let's see what that all comes to. Okay, so here we go. 800, open brackets, fraction, open brackets, 1 plus fraction, 15% over 12 to the power of 121 minus 1 fraction 0.15, 15% over 12, close bracket, and we get 223,725.82. Okay, so that's the final amount. 223. Notice I'm leaving a space just to make the number easier to read. 725 and 82. All right. Now it says Bongi leaves the money in his account for 2 years. Right, and the interest rate now changes to 10% per annum compounded quarterly. So now we're just going to use our standard compound interest formula, A equals P, 1 plus I to the power of N. Okay, and the P value is going to be 223,725.82. 1 plus, now my interest rate is 10%, but we're going to divide that by 4, because it's going to be compounded quarterly, and it's 2 years. How many quarters in 2 years? That's right, 8 quarters in 2 years. Okay, so here it is. Notice I'm not using the rounded off figure. I'm actually going to use the exact figure. So I'm going to go times by bracket 1 plus 10% over 4 to the power of 8. Okay, and we get 272,588 and 18 cents. 272. Okay. Right, let's look now at another one. Thando decides to start saving for a car. On his 16th birthday, all right, it says she deposits 5,000 Rand. It should either say his or her, sorry, maybe should be he. Okay, into a bank account. All right, I'm not sure if Thando's a girl's name or a boy's name now, so I'm getting confused here. Okay, but let's not worry too much about that. So, 16th birthday, 5,000 Rand. And then quarterly payments of 5,000 Rand until the last payment on the 24th birthday. Now, just be careful, because basically there will be, instead of, if we look here, from the 17th birthday, there will be 4 each year. Okay, so that's easy. But before here, there's going to be 1, 2, 3, 4. There's going to be 1 at the end of each quarter. So 1, 2, 3, 4. Sorry, that's 217. 1, 2, 3, 4, 5. That's right. Okay, so there are actually going to be, there's going to be 1 more. Once again, there's going to be 1 more. From 16 to 24, all right, that's 8 years. So 32 quarters. But just be careful, because of this one, there's going to be 33. N is going to be 33. Otherwise, it works exactly the same. And again, once again, if you use 32 by mistake, you're only going to lose 1 mark. Right, we're going to go straight into the answer here. The final value is going to be X, which is 5,000 Rand. 1 plus the interest rate is 18%. That's per annum, so we need to divide by 4 to the power of 33 minus 1 over 0.18 over 4. Let's see what all that comes to. Okay, 5,000, open brackets, fraction, 1 plus 0.18 divided by 4 to the power of 33 minus 1 over 0.18 divided by 4. Notice I haven't used the fraction button, I've used the divide button. Same thing. All right, and there's our answer. 363, 781, and 13. 363, 781, and 13 cents. All right. Here's another one. Jordan wants to save up to 250,000 Rand in 5 years to purchase a car. He starts paying immediately, all right? And again, because of this word immediately, we're going to have 1 extra payment. We're going to have, in 5 years, normally you would have 60 monthly payments. We're going to have 61. Okay. All right. So here's our formula. F equals X, open brackets, 1 plus I to the power of N minus 1 over I. Okay. And we want this to be 250,000 Rand equals X, 1 plus, the interest rate is 13%, but that's per annum, so I've got to divide by 12. All right, they're going to be 61 payments minus 1 over 13% over 12. And we want to know what X is. Okay, so what we're going to do is we're going to work out the number that's in this square bracket, and then we're going to take 250,000 divided by that. So let's do all that. All right, so let's work out what's in that square bracket. It's actually just 1 plus fraction 0.13 over 12 to the power of 61 minus 1 over 0.13 over 12. Okay, it comes to that. Now, if you look at this equation, 85,8x is 250,000. So we're going to divide both sides by this number. So we're going to take 250,000 and we're going to divide by that answer. And we get 2,913 and 64 cents. 2,913 and 64 cents. Okay, we're now moving on to the second type of annuity that we need to look at, and that's what's called a present value annuity. Okay, so before we even look at that, let's ask this question. Would you rather have 500 Rand now or 500 Rand in a year's time? Just want you to think about that. Maybe talk to the person next to you. Do you want it now or do you want it in 1 year's time? Okay, there's only one answer to this, and definitely now. Okay. All right, and the reason for that, okay, is if we invest the 5,000 Rand, if we put the 5,000 Rand into a bank, it will be worth more than 5,000 Rand in 1 year, because it will have earned interest. That's the one reason, okay? The other reason, which is similar, is that things are getting more expensive. So 5,000 Rand, it's not 5,000, it's 500 Rand, sorry. We wish it was 5,000, it's 500. Okay, 500 Rand. 500 Rand now £500 buys more now. You can get more stuff, whether it's bread or milk or whatever it is. 500 Rand will buy more now than in a year's time. So you're actually going to get more for 500 Rand now than you'll get in a year's time, and that is because of inflation. Things are getting more expensive. Okay, all right. Now, if I wanted to borrow some money from you today, and I said to you, I'm going to repay you 100 Rand per month for 5 years, starting 1 month from now. Okay, and you're going to charge me 12% interest. Okay, so I'm going to pay you a total of 60 payments of 100 Rand. But each of these is worth a different amount in today's terms. All right? Remember this formula? This formula puts interest onto an amount. Okay, it gives us the A value. If we rearrange it to get the P value, then we actually end up with A 1 plus I to the minus N with a negative power on. All right. Okay, and in this particular question, we're talking about interest at 1% per month, 12% per annum, 1% per month. Okay, so we need to work out the value of all these payments that I'm going to make back to you in today's terms. What are they worth today? Okay, the first payment that I'm going to make, this one over here, where I'm going to give you 100 Rand, that payment in today's terms is going to be 100, and I'm using this formula here. It's going to be worth 100. Remember the I is 0.01, that's 1%, to the minus 1. I'm going to give you that 100 Rand in a month's time. Okay, in today's terms, that 100 Rand is only worth, I'll tell you what it's worth, it's 100 times 1.01 to the minus 1. It's worth 99 Rand. Okay, 99 Rand. What that means is that if we put 99 Rand into the bank for a month, it would become 100 Rand. Okay, now the 30th payment, let's work out what this one's worth. That's this payment over here, where you give me 100 Rand. But you're only giving me that in 30 months' time, in 2.5 years' time. All right? That one's going to be worth much less in today's terms. Let's see what that one's worth. So I can just replay this calculation. All right? And we're just going to change that to 30. That one's only worth 74 Rand and 19 cents. And let's work out this payment here, the last one. The payment that I'm going to give you back in 5 years' time. I'm going to give you 100 Rand, but giving you 100 Rand in 5 years' time is not worth that much today. It's actually only worth 55 Rand and 4 cents today. So I'm going to give you all these payments in the future, right? But you're going to lend me some money today. The amount that you should lend me today is what those payments are going to be worth today. So what we're going to do now, we're going to add all of these up. All right? This is the first payment right through to the last payment. That should be 60, not 50. So I've just spotted that now. Okay, now this is a geometric series. You'll remember that we did those in term 1, I think. With A equals 100 times 1 plus 0,01 to the minus 1, and r is 1,01, that's 1,01 to the minus 1. And how many terms are there? Well, there's 60 terms. So we're going to use this formula. All right, and this formula says A is 100, 1,01 to the minus 1. R is 1,01 to the minus 1, but then we're going to raise that to the power of n, so it's going to be to the minus 60 minus 1 over 1,01 to the minus 1 minus 1. Okay, let's work out what all of that comes to. Okay, it comes to 100 times 1,01 to the power of minus 1, open brackets, 1,01 to the power of negative 60 minus 1 over 1,01 to the power of negative 1 minus 1. It comes to 4,495 and 50 cents. 4,495 Rand and 50 cents. Now, that's what all the 100 Rands that I'm going to pay you in the future, that's what they are worth today, in today's terms. All right. And this is how much you should lend me, or how much I can borrow from you. Right, but the difference, right, between what I'm borrowing, okay, and what I repay is interest. Okay, so we're going to generalize this now, because if we now change it to x, all right, here's the interest rate. Then this is just a geometric series with a equals x 1 plus I to the minus 1. R is 1 plus I to the minus 1. And n terms. Okay, so this is going to come to a is x 1 plus I to the minus 1. Then this is going to be 1 plus I to the minus n, because that's our r value raised to the power n, minus 1, over 1 plus I to the minus n, to the minus 1, that's our r value, minus 1. Okay, that's going to be the final answer. The present value of all these payments. Okay, now this formula is a little bit ugly, but we can improve it nicely if we multiply the top and the bottom by 1 plus I. All right, which we're allowed to do because this is just 1. This number over here, 1 plus I over 1 plus I is just 1. It just makes our formula look prettier, as we're going to see now. Right, because when this 1 plus I multiplies by this 1 plus I to the minus 1, they basically cancel each other out, because we get 1 plus I to the power of 0, which is 1. So on the top, all we've got is x into 1 plus I to the minus n minus 1. And on the bottom, we're going to get 1 plus I times 1 plus I to the minus 1. Those are going to cancel each other out to give us 1. All right, minus a 1 plus I. Okay, now this simplifies to x into 1 plus I to the minus n minus 1. And on the bottom, we actually now get 1 minus 1, which is 0, minus I. Okay, and the last thing we're going to do, we're going to change that sign on the bottom to a plus I, and we are going to write it like this. Inside the bracket, we're going to swap that minus sign around. Okay, 1 minus 1 plus I to the minus n. Okay, a little algebraic trick. When we change the sign, we change the order of the subtraction. That formula there is what's called the present value formula. You don't need to know this derivation that I've just done. Okay, but what it does it gives us, here's the formula, here's it nicely written in the form that it comes on a formula sheet. It gives us the value in today's terms, all right? It gives us the value, the present value of all these payments, and it assumes that the first payment is made 1 period from the date of the loan. Let's just quickly talk about that before we finish off, right? 1 period from the date of the loan. If I borrow 10,000 Rand from you and I pay back 500 Rand straight away, then I haven't borrowed 10,000 Rand. Okay, so what normally happens, we borrow money, then we wait a month or a payment period, normally a month, and then we start repaying. Okay, we're going to stop there. Next time we'll show you how this formula works. Okay, it's a really, really cool formula, but it's used for loans. Okay, have a great day, everyone.